Okay, so welcome back. This is part 2 in our series where we're going to develop this application. It's a C# Windows Forms application. And I encourage you to look at part 1 where we talk about the functionality of this and some design concepts and things we have to consider. So I encourage you to take a look at that. But basically, it's an application that resides on the desktop that gives us the date up here, the time that's updated every second, and it also gives us the outside temperature and it gives us the inside temperature. And in this series, we're going to look, in this part of the series, part 2, we're going to look at how we obtain this indoor temperature. And we're going to use an Arduino Nano and also a thermal sensor, and we'll talk about that. And as I mentioned before, we're going to have some additional information. This is a countdown timer here. Every 5 minutes, we're going to grab the temperature from the Arduino. And this just tells us we've got another update in 45 seconds. And this tells us how much time it takes. We're going to request the data from the Arduino and wait for a response. And typically, it takes a little bit over 1.2 seconds to make the request and get the response. So in this video, we're going to talk about the Arduino. We're going to talk about doing the sketch on the Arduino and writing the C# code. And we're also going to talk about generating a CSV file where we log the data, the time and the date and the two temperatures in the CSV file, so we can pull it into Excel and get something like this. And this is a chart I talked about in the first video where I was curious about the actual data behind when you have some GPUs in your computer and you're running them at high power. Does it actually warm up the room? And if so, how much temperature rise can you expect? And so this application helped me to chart that and see exactly for 2 GPUs exactly what I can expect for temperature rise and kind of cut through all of the mythology that's out there. So what we're going to do is we're going to talk about the C# Windows Forms application and also the sketch for the Arduino Nano. So here is our Windows Forms application in Visual Studio. And what I've done here is what I normally do in a Windows Forms app. I use regions to kind of put all the code together into understandable blocks. Okay, and I've got all my using statements up here, and here's a region that has my to-do list, which is presently empty. And to do a region, if you're not familiar, you just do a pound region and type in a name for the region. And at the end of the code that you want to block into a region, you do a pound n region. So I've got a to-do, and I usually follow that by documents. I am a believer that documentation is critically important with any software. I know a lot of people who write software hate doing documentation. I'm just the opposite. I think it is hugely beneficial. I mean, when you come back after 6 months or something and you look at your code and you scratch your head, what was that doing? Documentation, all you need is a few paragraphs to explain and get yourself back on track. Very, very useful. And we'll go through this. It gives kind of a summary of what our application is going to do, and it's very helpful. Then I have an initializing block where we just initialize a bunch of stuff. As you know, we're going to have date time, so I've got some date time stuff, and I've got some log data, which is basically I'm going to take this data and make a class out of it, and we'll talk about that, and then some other stuff. And this is just initializing the software. Then what I'm going to do, I've got my main form that doesn't have very much. It's just doing some initializing of the form. And I've tried to break the functionality of this application into 4 methods. Okay, so as we know, we're going to get outside temperatures from the internet. We're going to get inside temperatures from the Arduino, and we're going to save those to a CSV file. We're going to log them. So I've got 4 methods. Get web temps is one of them. Open COM port is another, where I basically open the COM port to the Arduino so I can read data. I can read the temperatures. And again, I've done a bunch of videos on the Arduino and serial communications and how to hook up the Arduino with C#. So I encourage you to look at that, but we'll go through how we do it with this. And then I have after I've opened the COM port, I'm going to get the Arduino Temperatures. And that's basically interacting with the sketch on the Arduino. And you can see here I've got some asyncs. We're going to do some, as we mentioned before, we're going to do some multi-threading just because it's fairly straightforward. We don't really need to. And then I've got saved to CSV, and that's basically going to use CSV helper. And it's very simple. It just writes our data into a CSV file. So basically the methods are get web temps, open the COM port to the Arduino, get the Arduino temps, and then save it to CSV. Very straightforward. And the real work here is, as in many cases, going to be done by these event handlers, and specifically this timer tick event handler. And we've got a form load. It basically starts the system timer that's going to give us a 1 second time event handler for the timer for the event handler. And this timer tick event handler is what does most of the work. It basically sets things up, gets the time, gets the temperature from the web, gets the temperature from the Arduino, and saves to CSV. This is the thing that gets called every second and goes through and does all the work. You can see here it gets the web temps, gets the Arduino temps, and then gets the data, puts it into a class, and then saves it to CSV. But we'll talk about that, but just so you get the general structure of this, this is basically what we're going to do. So the only other things I've got is I've got two classes. I've got one to get temperature from the web, and unfortunately this is fairly complicated. We'll talk about this in the next video, but basically we're going to a website called openweathermat.org, and it's going to give us the every 10 minutes it's going to tell us the temperature in our area. But you've got a bunch of other stuff you can get from that website, and we're going to need some JSON, and it's unfortunate for one number we got to go through all of this, but we'll talk about this in the next video. And then the only other thing I have is a class whose sole purpose is to hold the data that we send out to the CSV, the log data, which is the time of day, the inside temperature, and the outside temperature. And we save it as a class, and we instantiate the class for each time step, each 10-minute time step. And that's how the CSV helper, you just give it an object and it saves that to CSV. Very simple. Okay, so that's the basic structure. So let's go through this and take a look at how we've got this configured, and look at the Arduino, and then we'll go and look at the sketch on the Arduino. Now, one thing I need to show you is this form. Basically, it's just a bunch of labels. That's all it is. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, like 10 or 11 labels. But that's all I'm doing is I'm just updating labels. There's nothing fancy here, so I'll assume you know how to do that. You can label it however you want, but just add a bunch of labels and you're all set. Now, the other thing you may notice down here on the bottom left is a timer. And this is the main system timer we're going to use. And to do it, of course, you go over to the toolbox, and I'm at the all Windows forums, and it has all of the tools, and you go down here to the timer and drag and drop or double click, whatever, and you have your timer here, and you can select it. And over here on the right in the properties, the name is timer enabled. I start out with it not enabled, and then I enable it in the code. And I've got the interval set for 1,000 milliseconds, which means 1 second. So again, we're going to have an event handler that every 1 second gets this notification, and it's going to update the time, and then it's going to count every 300 seconds, 300 events, which is 5 minutes, and then it's going to do the work of grabbing the data and sending it to CSV. So that's our main system timer. So my using statements, I've got a bunch here. Of course, I've got CSV helper. I explained this in the previous videos, so I encourage you to take a look at them. But using CSV Helper. It's free library you can download. Go to your NuGet package manager, CSV Helper. Collections.generic, basically every time step, every 10 minutes, I'm going to grab this data from the Arduino and from the internet, and I'm going to save that as an object and get a list of those objects, and that's basically what we're going to send out to the CSV. And then system.globalization, I think I need that for some color stuff. System.io and IO ports, of course, we're going to be using the USB COM port for the Arduino, so we're going to need those. Windows forms, of course. System threading.tasks, because we're going to do some async and await. Again, I've got another video talking about async and await, where we do a subnet scanner. We scan IP addresses using async and await threading. And then system diagnostics for a stopwatch feature for getting timers, time durations. Okay, so again, if you want to copy this, just pause the videos and type it in. I'm not going to provide this code for you. It's fairly simple, and the good way to learn is to actually type it in yourself. So here's my main form 1. Again, the to-do has nothing, and let me just go through the docs real quick to give you an overall view of what we're going to have here. This app is driven by a system timer with an event handler that gets called every second, at which time the clock updates. And you can see that right here, this clock is updating. Also, that event handler counts every 300 seconds or 5 minutes, and then initiates the get web temps, gets the temperature from the openweathermap.org, and get Arduino temps. So every 5 minutes, I've just chosen to make it every 5 minutes to get the 2 temperatures that appear here. The outdoor temps, the app calls on openweathermap.org and grabs the local temperature based on the update timer seconds value, which is presently, again, we said 5 minutes, so it updates it every 5 minutes. The method is called getWebTemps, and we'll see that down here. The method is threaded using async and await, though this probably isn't necessarily since updates are every 5 minutes. And the UI response really isn't a factor, but we did it anyway. Note, openweathermap.org allows no more than 60 calls per minute for the free usage. You have to sign in and get an account, and you get free usage, but you can only do no more than 60 calls per minute. Though this app that we're doing here is calling only once per minute, so it's not an issue. Or once every 5 minutes, actually. It is unknown how often the website updates their temperatures, and it's unknown where the actual temperature measurement comes from. However, in my case, it seems that the data we receive is only updated about every 10 minutes, and it tends to give readings fairly similar to another website which I use, which is Weather Underground, that has temperature or weather stations located near my house. So I've checked on Weather Underground. So I've kind of matched a known local weather station to what I get from openweathermap.org, and it seems to match. And the weather station is about 2 miles from my house. Though it may differ by a few degrees on occasion, possibly partially due to the slow update compared to Weather Underground. This is one thing you need to keep in mind. The update times can vary a lot, so don't expect that you're going to get an update whenever you ask for it, it's going to be right up to date. No, it could be 5 minutes or 10 minutes or 20 minutes out of date. It seems the local weather station updates appear on the Weather Underground graph every 5 minutes, though the last reading on the chart may be from 10 to 20 minutes. So this is just saying that you need to check if whether your updates from openweathermap.org are within 5 minutes or 10 minutes or 20 minutes. Now, as far as the indoor temps we'll talk about here, this uses the Adafruit MCP9808 thermal sensor attached to an Arduino Nano. Typically, it connects to COM4 on my computer, though you can set that to whatever you want. The sketch and the Arduino, that's what I've called it. And we have a method that we'll look at, which basically requests data from the Arduino. It sends a T string command to the Arduino to request a read, and it's called every 5 minutes, and it's called at the same time as we call the get web temps method. And then finally, the CSV logging every 5 minutes again. When we grab the indoor and outdoor temps, the save to CSV method dumps the accumulated list of log data, and that's this class right here. We instantiate an object every 5 minutes and add it to the list of log data. It continually accumulates each date, time, inside temp and outside temp reading, and it sends it out to a CSV. And I decided to just each 5 minutes overwrite the existing CSV with this whole list of all the previous readings. So you can change that, but that basically helps you to understand what's going on here. So as far as the Arduino, I'm not going to go through all of these other than I'm setting up a serial port called Nano port. And for me, the COM port is going to be, I'm setting up a string. The COM port number is 4. And here is my list of log data of these objects from this class. And that's about it for the initializing. Then, as we said, there's these methods. There's the get web temps. And what we're going to talk about now is the open COM port, the get Arduino temps, and the save to CSV. Okay. Now, again, I've talked about this Arduino C# access using the COM port, so I'm not going to go into too much depth here, but basically it's fairly straightforward. We instantiate a new serial port, and again, we're using the System.io and System.io ports. I'm calling it the Nano port. We're setting the baud rate 9600, whatever you want, and the name of the COM port is com plus this text.com, which we initialize to 4. Okay, so we're saying the port name is COM4. So what we do is we try to open the serial port called Nano port. If it fails, I catch the exception and just throws up a message box that says, dude, seriously, you need to like plug in the device first and then return. Okay. In our case, it's not going to be that big a deal because you set it up once when you start up your computer, and it's usually okay. It's not a big problem. You can add more exception catching, but to me, it really doesn't matter. So you just start up the port and you're all done. And then the get Arduino temperatures is again very straightforward. What I'm doing is I'm setting up a stopwatch, and that's from the system diagnostics. And I'm calling it watch, and this says every 5 minutes this reads just a single temperature in degrees Fahrenheit, which contain only something like 72/R/N. So what we get from the Arduino will look like a number and a /R/N for a carriage return line feed that you normally get. So of course we're going to have to strip that out and convert this to a number. Note that the serial port read line method will wait until it receives the /N character. And again, we talked about this in the previous Arduino C# code videos from the serial port, which means it has to wait on the Arduino to respond. However, this app sends a specific request to the Arduino to send a reading, and it tends to respond in under 1.3 seconds. Remember, we looked at this and we actually timed it, and we'll show how we time it here, but it's 1.271 seconds, right? And that's fairly consistent. Also, I clear the COM port input buffer so it doesn't accumulate old temperature readings. May not be necessary, but I just do it because it can't hurt, just to make sure we're clear before we read. So I do a nanoport.discard in buffer, and that clears it out. And then I send a request to the Arduino, and I go nanoport write and a T. That means Arduino send us T for temperature. And then I start my stopwatch so that I can count this response time. And then I say I await task.run nanoport.readline. So I'm waiting, as we talked about in another async await code video. Nanoport. I read one line, and there should only be one line because I requested just this line that's going to look something like 72/R/N. So I'm waiting for that using await task.run, and that's going to give me a string, the Arduino temp now, and I've initialized that back in the initialized section. So I've got a public static string Arduino temp now, okay? And then once I get it, I stop the stopwatch, and now I've got the elapsed milliseconds. So now what I can do is I can put into the label the Arduino temperature, Arduino temp now, and then I can put into the other label the string.format with the elapsed milliseconds, which is the watch, the difference between the start and stop time, and I do it with this format where I format the number and put milliseconds, okay? So really it's pretty straightforward to get the Arduino temps. You just open the COM port and then ask for the data, request the data and wait for it, and then fill in the these numbers. What I'm going to do next is look at the save to CSV. So the save to CSV is very simple, and you can just copy this. We've done it before when we talked about CSV helper, and it's just taking the data that we brought in from the Arduino and instantiate a class of this log data and add that to a list of these log data objects. And so every time we do this, we add to the list, and then we can just write those records. So now that we have a basic understanding of the functionality here, and I've got my simple methods that are going to be doing the work, I want to talk about the real center of all of this, which is this event handler that gets a 1 second event from the system timer, and it's a timer tick event, and it's going to go through every second and do the work. It's going to, of course, it's going to update this clock time, and then every 5 minutes it's going to update the temperatures, and it's also going to write out the CSV. So here's the timer tick, and I've got a what I'm doing here is I am setting up the date and time every second, and that's what these do. These 3 lines, all they do is they update this time and date every second, okay? Pretty straightforward. I have time now string, date time now to string, and I'm formatting it as hours, minutes, seconds. And also I've got the time and date set in here, so you can see that. So here I mentioned we've got the uptime, which tells you how many days, hours, minutes, and seconds this application has been running, and it gives an idea of how much data has been stored in your CSV file. So I've got 12 hours, 52 minutes, and 39 seconds worth of data stored in my CSV. And to do that, in the beginning here, when we initialized, we did the uptime. We defined a date time called uptime start and said that was date time now, and that happens when you first start the application. So this holds the starting application start time as a date time, and then what we can do is we can take the uptime is we take that starting uptime and subtract it from the date time now, and that gives us a time span called uptime, which tells me how much time has passed since we first started the application. So now I can just send that to this label by just formatting the uptime, and the way I'm going to do it is I'm going to do a string.format, and I'm going to say uptime is days, hours, minutes, and seconds. And to get those individual bits of information, I've got the uptime, which is a time span object. Uptime.days returns the days. Uptime.hours returns the hours, minutes, and seconds. So if it's a time span, you can extract the days, hours, minutes, and seconds by just saying uptime.days, blah, blah, blah. So that's how I can put that on this in this label. So I've got that string. Now I can just print that out to the label on the form. Okay, so that gives us the uptime. Now I've got the countdown timer, and when we go back here, we've got the countdown timer is set to this 300 seconds, which is 5 minutes. And all of our grabbing data and sending to CSV are going to be done every 300 seconds or 5 minutes. So countdown timer starts at 300 seconds or 5 minutes when you first start the application. And what we're going to do every second when this tick event handler gets called, we subtract 1 second from that 300. And the purpose of that is to count down and tell us how much time is remaining until the next update from the Arduino, okay? The next time we're going to grab it, we're going to, in 1 minute and 20 seconds, we're going to grab it because 5 minutes has passed, and every 5 minutes we grab it. So this is going to give us the time remaining every second. When is our next grab from the Arduino? Here we're going to do the work of actually grabbing, calling the methods that grab the data from the web and from the Arduino. So if the minute timer is greater than update timer seconds, and the update timer is 300 or 5 minutes, so if the minute timer is 5 minutes or is greater than 5 minutes, we're going to actually go out and grab the temperatures. Here's the web temps we'll talk about in the next video, and then the get Arduino temps that calls the method that we showed before for the get Arduino temps. All right, basically just sends out a T and waits for the response. Now what we're going to do is every time we gather the data, we're going to instantiate a log data object. Again, this is the class that all it does is holds time of day, internal and external temperature. So we're going to instantiate a log data object for each sample and store the time, temp, internal temp, and external temp. We also want to format the time and date so that Excel can read and chart it correctly. So what I'm doing is I'm saying the time now string that we're going to send to the CSV for each data grab is a date time now to string, and we're formatting it this way because this is an easy way for Excel to read it. So I've got month, day, year, space, hours, and minutes. Here's where I instantiate a new log data object. There's the class. So I've got my time, I've got my internal and external temps, and I'm going to instantiate a new log data object and fill it with the time now string for the time of day. All right, that's the time of day. And then for the external temp, the web temp now, which we got from the get web temps, it uses this public static float web temp now, and then Arduino temp now. These are public static properties, so we can just access them easily from here. So it's basically filling in, instantiating and filling in a log data object. And the nice thing about CSV Helper is you can just add each object of data to a list, and I'm saying log it is that new object, and I'm adding log it to this list of log data, okay? And up here you can see we've got the list of log data, which is log data list, all right? So every time we grab the data, we make an object out of it, put it into this list of log data, and then save to CSV. This method that we showed before basically just saves that log data, okay? So we can go here and see log data list, CSV write records, log data list. So every 5 minutes it adds to the list and stores and overwrites the file every 5 minutes, okay? So that's about it. Then we are just taking our minute timer, setting to 0, and then incrementing, and that's about it. Okay, so here is our Arduino Nano here on the left, and I've got my USB connection to my desktop. And on the right is this nice tiny little MCP9808 by Adafruit. And it's a fairly accurate temperature sensor, very nice. And here is the Adafruit website on it. It's like $4 US in stock. I2C temperature sensor breakout board, and you can see the specs. It's typical accuracy of 0.25 degrees C over the sensor's minus 40 C to 125 C range. So the connections, you can see I've only got a few connections. I'm just taking +5 and ground from the Arduino and connecting them to the MCP. And I've also got the I2C connections. I've got 2 connections. On the MCP, there's an SCL and an SDA. So I need to connect those 2 to address buses or address connectors on the Arduino. So if you look here, on the MCP, I've got VDD as the first pin, and of course that's the +5 volts. So I connect it with this green wire over to 5 volts on the Arduino. Then I've got ground, which is connected to this green wire, goes over to ground on the Arduino. And then SCL is this black wire. You can follow it out here. The black wire goes over to the A5 address line on the Arduino. And the SDA is this white wire, goes over to the A4 on the Arduino. So I'm just using the A4 and A5 address pins and then a 5 volt in ground. Very simple to set up. Okay, so now let's take a look at the sketch on the Arduino. And it's fairly straightforward. Again, most of this is being able to access the MCP 9808 temperature sensor by Adafruit, and we'll take a look at that on the bench and show you what it looks like. But it's basically an Arduino Nano with this temperature sensor. Now, what you can do is you can go in here to examples, and you can go down to Adafruit MC98808 library, and it's got some demo code and everything. What I'm doing is just a small subset of that because we don't need all that. But that's basically, you need to include that library, Adafruit MCP9808.h, and then create a new sensor. We'll call it Temps sensor, which is an Adafruit MCP9808. And then I've got a receive value, which is a string that we're going to use down in here. Again, basically this code is only executed once when the Arduino is initially connected. Assuming it's left on and connected continually, there's really no need for error checking to make sure you can find the thermal sensor, because once you found it, you're good. And then it waits for a T character to arrive from the C# application. Remember, we mentioned that we're going to send a T from the C# application, and that's a request for the Arduino to read and send the latest temperature. It also wakes and sleeps the thermal sensor when it's not being used, and that's clearly in order to save the planet. So we've got a void setup, and we're going serial begin, pretty standard, 9600. This is code from the example. It says, if not temp sensor.begin at this address, then serial.println couldn't find the MCP9808, check your connections, blah, blah, blah. So this is just needed when you start it up. You should be okay and probably don't need it, but it's here in case you want to expand on that. And then, assuming you've got the temp sensor connected and all set, you just set the resolution. I set it to 3, which is 3, I believe it's 3 decimal points. So basically in the loop, it's waiting for the T sent from the C# application. So if it gets that T, which is a request from the C#, if serial.available, then read that string and call that receive value. If receive value starts with T, because it may have characters after it, like a carriage return line feed or whatever, if it starts with T, we know, oh, okay, it's a request from C#. We're going to wake the temp sensor, and then we're basically just going to read temp F from the temp sensor and assign that to F, which is a float. All right, so we've read the float from the temp sensor, and we do a serial print line F1 to send that temperature to the C# application. It's basically a float with 1 decimal point. And then we do a 2000 millisecond delay and then shut down the temp sensor because it uses 0.1 microampere of current, and apparently somebody thinks that's too much, so they have to shut it down. So anyway, okay, so that's about it for this part 2. I think in the next part it's going to be the last part, and we're going to cover getting the temps, the outside temps from the web using web APIs, and show how to do that. Unfortunately, it's a little bit complex just to get one number, and honestly, I'm not real interested in going through that again, so I'm not sure what I'm going to cover in part 3. And honestly, I've noticed that whenever I do a multi-part series, very few people watch part 2 and far fewer watch part 3. Nobody sticks around. So I think I just might make part 3 a short summary of some of the data I gathered and some of the things I learned about GPU, warming up your room and that kind of thing. If you care about doing the web API, leave a comment. Otherwise, take care. Have a really good day. Thanks.